Hey guys, this video is the last video that we're going to talk about converting between grams and moles and molecules. So hopefully you feel pretty comfortable with all of the stuff we've talked about up to now. Before we learn anything new, I just wanted to do a really super quick review of Avogadro's number and molar mass. So remember, Avogadro's number is 6.02 times 10 to the 23rd. And that is the number of anything in a mole of that thing. So, I mean, you could count pencils, like you could have a mole of pencils, and that would be 6.02 times 10 to the 23rd pencils, but there aren't that many pencils in the world, so we don't use Avogadro's number for big things, we use it for molecules and atoms. And we learned how you can use it as a conversion factor. So in this problem, for example, it says how many molecules are in 0.25 moles of H2O. So we put the 0.25 in the top left, and then we use Avogadro's number as a conversion factor with moles on the bottom, because 6.02 times 10 to the 23rd molecules is equal to 1 mole. And then moles cross out, and then we just multiply across the top to get molecules. Okay, so that's Avogadro's number. Now we also talked about molar mass. And remember, the molar mass is the mass of 1 mole of any element or compound. And you find it on the periodic table. So, for example, we looked up lead. The number underneath lead on the periodic table was 207.2. So that's the number of grams of lead in 1 mole of lead. And then, of course, you can use this as a conversion factor too. So, for example, we converted 1.6 grams of NaClO into moles by finding the molar mass of NaClO, which is bleach, and putting that on the bottom to cross out grams and get to moles. Okay, so that was a quick 2-minute review. Now, we're going to go into something new, and I'm actually going to have us write this down on the very first, title page, because this is something really important that you're going to want to come back to, and also because we ran out of room on the other pages. So, this is going to be kind of a road map. It's going to have 3 kind of ovals. That is not a very good oval. Sorry about that. Connected by lines. This one's going to be grams. This one's going to be moles. And this one's going to be molecules. So these are the different units we can convert between with Avogadro's number and molar mass. So let's say I start with 2 grams of water, and I want to know the number of molecules in 2 grams of water. There's no conversion factor that will help me go straight from grams to molecules. What I have to do is go from grams to moles, and then from moles to molecules. And I can also go backward from molecules to moles, and from moles to grams. So we're going to write down the conversion factors that you use to go between each of these points. So between molecules and moles, we use Avogadro's number, so 6.02 times 10 to the 23rd molecules, or atoms. This can actually be atoms up here too. Usually it's molecules, but sometimes it's atoms, per 1 mole. Okay, now to convert between grams and moles, we use the molar mass, which is different for each element or compound. So it's just whatever number you get from the periodic table, but it's always over 1 mole. And just to remind us, I'm going to write down here from periodic table. So you can kind of use this little chart as a guide when you're solving problems. So we're going to do a couple of examples. If you were in class, I printed these out as little tiny pieces of paper, and we're going to try and fit them in on page either 19 or 20. So if you're at home, you can just pause the video here and write out the question, and then we'll write out the answer, the solution below it. Okay, so it says isoamyl acetate is a molecule sometimes known as banana oil because it smells like bananas. If I isolate 0.03 grams of isoamyl acetate from a banana plant, how many molecules have I isolated? Okay, so if we look at our chart, And our problem, we're starting with 0.3 grams. So back to the chart. We are starting in the grams circle. And the problem is asking me for molecules. So I'm trying to get from grams to molecules. So that means I'm going to need to use two conversion factors. First this one, and then this one. So I'm going to set up my grid. I'm going to leave lots of space because it might take a lot of room to write these conversion factors. So 0.03 grams, and I'm going to write out the compound. C7H12O2. I just got that from the problem up here. Okay, so I need to first get from grams to moles, and then from moles to molecules. So again, I can just follow this chart. If I start in grams and I'm trying to get to molecules, the first step is to go from grams to moles. And the way to get there, like the road that I need to travel by, if you will, if you think of this as a map, is this molar mass conversion factor. So that means that I need to calculate the molar mass of isoamyl acetate. So I'm going to do that like down here. So C7H14O2. There's 7 carbons, so I have to look at carbon on the periodic table. Carbon is number 6. Its molar mass is 12.01. So we're going to do 7 times 12.01 plus 12 times hydrogen, which is 1.008. You can look that up if you want to, or just trust me. And there's 2 oxygens, which is 16. And if I grab a calculator and calculate that out, I get 7 times 12 plus 12 times 1.008 plus 2 times 16. I get 128.096 grams of C7H12O2 all over 1 mole of C7H12O2. I know this is tedious to write out all these units, but it's very important. Okay, so we want to cross out grams, so we're going to use the 128.096 grams C7H12O2, and then 1 mole will go on top. So grams cross out. Okay, so now what I have basically done is I've gotten from the grams circle to the moles circle. Now I need to get from the moles circle to the molecule circle, because that's what the problem was asking me for. So I use this Avogadro's number. So I want to cross out moles, so I'm going to use 1 mole of C7H12O2 on the bottom, and 6.02 times 10 to the 23rd molecules. And I should write the name of the compound after that, but I think I'm going to run out of space. So I'm going to not do that step. Then we're going to multiply everything on the top. So we'll do 0.03 times 6.02 E23. So that's 1.806 times 10 to the 22nd molecules. And then on the bottom, I've just got the 128.096, and there's no units on the bottom now because moles crossed out right there. So I just need to do 1.806 times 10 to the 22nd divided by 128.096, and there's my answer. It's 1.41. We'll round it to 1.41 times 10 to the 20th. So don't know where to write my answer. 1.41 times 10 to the 20th, molecules of C7H12O2. That is my answer. Sorry, I should have given you probably more space even than I did. But hopefully it makes sense how you do that. It takes kind of a long time. It's a little bit tedious, but it's not really new from anything we've been doing before, just kind of putting some steps together. I'm going to do one more example. that's going backwards, going from molecules to grams. So you can write down this problem wherever you have space. This one's a little bit shorter. It says if you have 4.25 times 10 to the 25th molecules of HCN, how many grams do you have? So if I look at my chart, I'm starting at molecules and going to grams. So I'm going to need two conversion factors again. My first one will be Avogadro's number, and my second one will be the molar mass. So I'm going to set up my chart again with space for my number that I'm starting with, my given, and my two conversion factors. I do need to find the molar mass of HCN. So we'll do that really quick. Hydrogen is 1.008. Carbon is 12.01. And nitrogen is 14.01. You can look those up if you want, or just trust me on that. And we'll add those up. Oops, 12.01. So that molar mass is going to be 27.028. I'll just round it to 27.3 or 0.03. Okay, so we've got our molar mass ready whenever we need it. So let's put our given, 4.25 times 10 to the 25th molecules of HCN. Okay, so I don't want to use the molar mass yet because there's nothing there that will cross out molecules. So what I'm going to use is my 6.02 times 10 to the 23rd molecules of HCN in 1 mole of HCN. So molecules have crossed out now. Now I want to use the molar mass, and I want grams to be on top and moles to be on bottom, so that moles will cross out. And then I'll end up with grams, which is what the problem is asking me for. I want mass. All right, and then I'm just going to multiply across the top. So 4.25, 4.25 E 25 times 27.03, and that is 1.15 times 10 to the 27th grams of HCN. And then on the bottom, I still have my 6.02 times 10 to the 23rd. So we'll just take this number, divide it by 6.02 e to the 23, and I end up with 1,908 grams of HCN, which is a lot of grams, but that's a big number of molecules. That's like a lot of moles. So makes sense that it's a big number of grams. All right, I know that was a lot of work for just 2 problems, but hopefully it makes sense. If you have any questions, feel free to email me. Happy to answer any questions that you need.